You have officially joined the first workshop of the Hack-a-thon Preparation Series. And I'm the president of SF Hacks. My name's Alicia Murthy. If you look in the room, you'll probably see some other officers in here as well. So what is the Hack-a-thon Preparation Series? SF Hacks and ACM, we wanted to launch this because SF Hacks' main purpose as a club is to host hackathons. And the one we planned in March 2020 was canceled due to COVID, along with everything else in the world. So it got pushed to March of 2021. And until then, we wanted to create a series where students can come learn about CS topics and then eventually apply them to the hackathon that we will have. We're also the largest collegiate hackathon in San Francisco, which is pretty cool for our club and the school in general. I'll hand it off to Melissa.
Hi, I'm Melissa. I am the president of the Association for Computing Machinery. ACM provides a lot of resources, both internationally and especially to students. So we will be having a lot of different events. We'll have speakers coming in. We're co-hosting the SF Hacks Hack-a-thon Preparation Series and a lot of other events, an alumni panel later in the semester. So keep an eye out on Slack. We'll be posting all the announcements there.
Awesome. And we can start with Heidi's presentation and I'll hand it off to her. Let me stop sharing my screen and Heidi can take over.
Thank you. Okay. Okay, first introduction myself. I'm a definite alumni. I graduated 2005 with a master's degree in computer science. It's hard to believe it has been 15 years. I still remember my days at school. It was fun and great. I want to mention this, my most favorite classes are two graduate level classes. One is Advanced Operating System taught by Arnold Puder. And the other one is Analysis of Algorithms by Dr. Wang. A lot of thinkings in those classes, but I learned a lot. And my least favorite class, ethics. It's not that I don't like the content. I definitely appreciate what they taught me in that class, but I really, really didn't like writing essays. I'd rather write code much more. So that's the reason I didn't like it. And that was the only class I didn't get an A. Right now I'm at Pure Storage. After I graduated, I went to work for OSI Soft at East Bay. I stayed with them for a long time, 13 years. And then a little bit more than 2 years ago, I moved to Pure Storage. Through my career, I started as a support engineer, and then I gone to escalation engineer, then developer. Now I'm a tech lead. I enjoy being a tech lead. I still very close to technical stuff, still read code and write code, but also I kind of be able to help other people to do development and leading projects. The pictures here, one is at my graduation. See how young my son was. And the other one is just recent. He's grown a lot bigger than me. He's the age about you guys. He's a sophomore at UCSD, 18 years old. And before I prepared for this workshop, I never used GitHub before. So I asked my son, can you show me GitHub? And I asked him to get involved. So I asked him to join me later in case there are some questions I'm not able to answer. I would like you to help me out. He agreed, but he said he's not very good with GitHub either. We will see. Now, okay, let's go to technical. First of all, what is Git? Can I see a show of hands? Can I see everybody? If you have heard of Git or know a little bit about Git? Not bad, you have some. So a Git is, first of all, it's a version control system. So I guess as a student, if you have not worked on big group projects, probably usually what you do is you write some code on your computer, you have your source files there, and then you make changes, and sometimes you make some change you don't like, you want to you maybe redo it. But version control systems provide two big features. One is history tracking. You can track what changes you have made. So you can look back and see, oh, I was doing that before and then I did that later. And or if you try something and it's not working out for you, you can revert to an older version of your code and start from there again. Another advantage is allows collaboration among developers. So basically you have this version control system, everybody uses it. You can share the same code, you contribute to the same code. And Git, it's different than those more traditional version control system in the way it's distributed. So on the drawing here, on the left side is Apache Subdivision or Microsoft Team Foundation or some other ones. You have one central repository, and then your users just pull contents out of that repository and push contents back to that repository. On the right side is Git. Git have a remote repository, and then every individual can create their own local repository. They can make changes to a local repository, do different things. They can push to the same remote repository. I'm going to move forward with GitHub. So I hope you're not confused and thinking Git and GitHub are the same thing. So we talked about what Git is. GitHub actually is just one of the many Git repository hosting servers. It provides you all the Git support. You have the repository there. You can pull things out. You can push things onto it. But on top of that, it provides a web-based graphical interface, a UI, which can be really nice if you are not a command line savvy. And also provides access control. So on GitHub, you have an account, and then for different projects, they have permission controls. Like, okay, I want this group of people to make changes, and the other group of people can only see my code but cannot make changes. Have that control. And also it provides some tools like wikis for you to write up what you found, task management. That one's probably not used much by students, but at work we do that. That's to keep track of what things need to get done for the project, and you can mark them done when you finish. And because it has all these tools and have many developers have created their repository and contribute to other people's repository, commented on each other's code, have discussion. GitHub actually also a network for developers. And I don't know if you have heard, like when you look for jobs, sometimes people may say, oh, can you show me your GitHub? And so they can see what's out there. It's a network platform now. GitHub is really big. And as of January this year, this is the latest data I found. There are over 40 million users and over 100 million repositories. And I think the Bitcoin is a very interesting one. It's big, it's important, it's hosted by GitHub. And another interesting one is this free programming books I found. It's actually not code, but people post a lot of free ebooks there. You can go read it and learn about programming. Yeah, and then tons of other projects. And you probably will create your own repository today or near future. Any question about Git and GitHub so far? Okay, now we are going to dig more. I'm going to show two windows. One is the slide and the other will be actually when I run my commands. So when I run my commands, I will try to slow down so people who wants to follow what I'm doing will follow. And I will, from time to time, I will check the video of the Zoom and see if people are still working or feel puzzled and get some feedback there. First of all, let's create a repository. And I just find it much easier to do it on GitHub rather than command line. So we're going to do it on GitHub to create one. Let's go to the GitHub homepage. I have a field that I played with. Here's a new, let's create a new one. Let's give it a name. I'm going to call it demo. Demo for Git work. And you can specify public or private. For mine, I don't care. I'm not going to put anything important there. I don't need to protect it. I'm going to make it public. And there are some things that Git provides you. You can add a README file about your project. The Git ignore one can be useful. So for Git to work, it needs to keep track of files in your project. But sometimes, for example, if you've done C, when you compile, it generates those intermediate files like .o. You don't want Git to keep track of those files. You don't want to push those files to your repository. So you can choose. They have different templates, depending on your programming language. And a lot of things I don't even know what they are. I'm just going to do C++. That's open source license. You can choose one. I'm not going to do it. Create. Now we have a repository. And here, that's my account, my repository name. This is the URL of your repository. That's a very useful information. So we finished creating this repository. Now let's clone it onto our local machine. I should show you the commit in there if I can find it. So when I create this repository, it has the initial commit. It's called commit. Basically something you committed to Git some changes. So here we have an initial commit in the repository. I'm gonna do, I already in the right folder. I have a GitHub folder. In here, I'm gonna have my repository. So I'm gonna do git clone and then the URL of my repository. Very quick and easy. So at this step, I might arrow draw wrong. Clone, it puts remote onto your local. And then let me show you this. So we have the demo folder. Let's go in there. So this will be what's in your local repository. And let's see what the Git history says. Git log shows the log, it shows all the commits. So we have my initial commit. So that's the initial commit there from the remote through clone. We copied it over to our local system. And then here it tells you some additional information. That's my head. That means this is the top of my commits in my branch, in my repository. And that's also origin main means the main branch on the remote repository. So on the remote repository, we are also at this initial commit. Origin head on the remote repository, it's also the head. I don't understand why they call this initial, the default branch main. Most cases, it's called master, but they call it main, we will just do it main. All right, so we finished the very first step, got a repository on a local machine. Now let's do the next. We will do some work. You need to write code. right? So let's do that. I'm not going to actually write code, it takes too much time. So now I've created a new file in my local repository. I see it when I list it. Now let's see what Git thinks about it. So we say Git status. Here it says I have untracked file, file 1. What it means is that Git finds this file in the directory, but Git is not tracking that file. So for any new file you created, you need to tell Git, I want this to be part of my Git, please check this file. So what you need to do, you say git add, you give the file name. Sometimes if you have multiple files, you can just do a regular expression. Or if you want to add everything in your local, in this directory, you can just do a dot. Now let's see what Git says. So now it's tracking that file. Tracking, as I mentioned, it's also, Git uses a kind of index database to track files. You tracking that file means you added that file to its index. People are following along so far? You don't type it? Okay. Now here, this is tracked, but then it knows there's change in this file, and this change has not been committed. We have not said, okay, Git, I want to commit this change. I changed one. It's good. I want it to be there. Let's do another thing. Git diff. No, too late. Another time. Git diff, where we show your differences. So far, because we added it already. Now we have our change not committed. So once you're writing code, you run it, you make sure you can compile, doesn't have obvious bug, you can commit it. What you do is git commit. And it will give you a window to type your commit message. This is when, okay. This is the first commit. And here, what you type, it will be message. And then whatever here, the pound, just some kind of comments. It will not show up in your commit. So after that, I'm going to save it. So I've committed my change, this new file. Let's look at his log, see what it shows. So it sees my commit, it's in there. And in this output, this long number, we call it the SHA number of the commit. That's what you will use to refer to that commit. Now we see that things changed. We have head main, so that means our local, our head is on this commit. But on the remote repository, the head is still pointing to the initial commit because remote doesn't know our change yet. So we are now in the drawing on the left side. We've made the first commit here. That's what it looked like. Let's do something else. Okay. Long. One. And something. Now we've modified the file. Let's look at what Git knows. Git status. So it tells you this file has been modified, but it has not been staged. So for you to commit something, you first have to stage it. Like I have something ready, let me stage it, and then let me commit it. Earlier when it's on this state, the file was not tracked. But once we did an add, it tracks it and stages it. Now now the file is already tracked, but our change has not been staged. So what we need to do now is, I should do something else before I do that. Git diff. So git diff shows you the difference between what has not been staged with what has been committed. And here says we added something. Now let's add that file. That will stage it. So now the file is staged. It tells you it's ready to be committed. Git diff does not show me the difference anymore because it has been staged. Okay. Now let's commit it. So when you commit, actually, you can do it in one step, -A. If the file has not been staged, you can do -A. It will stage it for you. And then there's another one, it's -M. And it's that I'm going to provide my commit message. So rather than going to the Vim editor to edit the commit message, you can just do it here in this line. So this is the second commit. Let's see, git log. A second commit shows up here. Our head moved, remote has not changed. Git status should say there's nothing different, we are good. And it tells the branch is ahead of the remote one by 2 commits. All right, now let's try. Before I move forward, people okay following? All right. Now let's push whatever we changed onto the remote repository so that you have a copy somewhere else. Simple. Push. It's been a while. So it pushed from a local main to remote main. Nothing changed on our side because just pushed. We still have 3 commits. Now let's on the remote, look at the remote repository. That was what it looked like before. So now the file is there. The commit is there. It shows this is the second commit. It's the latest commit. And then you click on there, you can see what change were in that commit. So what we've done here, originally we have remote only 1 commit, local 3, we push, your changes get into the remote. Next. Next is a more interesting concept of branching. Sometimes it can confuse people a little bit, just because branching, like the concept, I guess. You can think of a branch as a tree. So here, I'm gonna do the git branch command. It will show me all the branches I have in the repository. And since we have not done create any branches, so we have the default main branch. And we use branching a lot at work. So at work, we keep this main or master branch that's shared by everybody inside of a company. And we want that branch to have a stable code. We don't want to have bugs in them. And then when the team need to develop a feature, because during development, you for sure going to write bug, you for sure try something, you want to revert it, retry. So the team will need to create their own branch, and they will work on their own branch so that their change will not be in the master branch and will not affect other people. Once the team finish or close to finish their work, feel confident about their work, they push onto the master branch. So that's how we use branching. To do it, it's quite simple. Need to create a new branch. Let me see what's my branch name. Test branch. let's see. We create a branch. Now we want to do some work in our test branch. So we will do git check out test branch. We switch to it. So if you check, it shows that we are in test branch. Now we'll say we have to work. We write more code. Right. Okay. So we see our files, file 1, file 2. This file is untracked. So we have to edit again. Okay, let's commit it. Commit -n. I should first commit in test branch. All right, we made our commit. Let's look at the log. You see the latest commit in here, and it's telling me this branch's head is here, but the remote repository and the main branch's head is there. So whatever change we made here only exists in our own branch. Let me show you. Let's see. So we're back to the main branch now. Let's see. You list your file, you don't see file 2 because your branch does not have file 2. It only exists on the other branch. So the git log will not show anything that's on the test branch, only on the main branch. All right. Let's see, did I do everything I want to do? Yeah. Yeah, okay. So when we branch, we made something, and this new branch brings over those 2 old commits from where you branched from, 2 commits. And then we made a change in the local branch. Let's say we know this good code is good. We want to go back to main or master so that other people can see it. We have to do a merge. So we are not in our target branch main where we want to merge into. We say we want to merge test branch into here. It's done. Now let's look. Now the main branch has file 2. And the main branch has this commit. There was something else, but not interesting yet at this time. This more the graphical view of your commits. We have 4 commits as expected. This will be more interesting later. All right, so now we've merged to master. So our commit got into master. Let's do something more interesting. Do I need to slow down a little? You guys able to run your command? Okay. Let's say we do something in the main branch. This from the main branch. Okay, let's commit this change. Main branch. We've committed a main, and you see test branch is there. Let's check out test branch. Let's do the same thing. Let's update that file. Oops. Update from the test branch. Okay, let's commit it to. So yeah. So here we see that the file is changed but not staged. I'm doing this git commit -a to edit -m to write the message. They did in the test branch committed. And so we see our commit. Now let's do a merge and see what happens. Let's go to main. Let me show you this for LG. So it's still similar. We have one thing going on, several commits. The commit from main branch is here. Let's do git merge test branch. What does it say? We have conflicts because you made the change to the same file, the same line on both branches. We need to resolve the conflict. There are tools. I think there's a git merge tool. I have not used it for so long, so I don't know the syntax. I'm just going to do win. So here it shows, you see those strange characters. That's to show you where the conflicts are. It's saying that on the head of this main branch, that's the text. And on the test branch, that's the text. And we want to keep both. Sometimes when you have conflict, you have to be careful, like what code you want to keep from this branch, what code you want to keep from that branch. It's not all the time you want to keep code from both branches. In this case, we're keeping both. So I'm just deleting the markers. We have both. So let's say, so we were trying to merge and it reported conflict. What does it say? It says, I have unmerged path. And it tells you what to do next. Fix the conflict around git commit, or you can abort the merge to revert back to what your master or your main was like and forget about what you took from the test branch. But here we are going to merge. So we resolved the conflict already. And then it says this unmerged things and tell you what to do. So we added the file to resolve the conflict, but to git, it doesn't know that yet. So you need to do git add to tell git that I've resolved the conflict. All right, so we are done. And I need to commit this change now. Let's see git log. What does git log look like? So git log still just saying the update from main branch. Let's commit this. Merge test branch. Okay. So with this merge, that was where we were before. We had updates from main branch. This merge brings in the commit from the test branch. And then you have one, I think that happens only when you have conflict. I may be wrong, don't quote me. So you have an additional merge commit. This one is the merge work that you are doing. And we know that test branch's head is here, our head is here. Let's see, git LG. It shows you the branching. So those was the original ones, things we did in main. And then from this char, this commit, we branched out to test branch. In test branch, we made this commit. In the meantime, in the main branch, we made this commit. So there are two branches. And we merged. We merged that into the main, and that's the merge commit. So this drawing is kind of like what I have here. I just have some additional dots. So earlier we finished this and we made a commit on the test branch. We made a commit in the main branch. We merged. We brought the test branches commit into the main branch. And we also had a merge commit. Any question on this? Anybody need additional time to do some typing? Not hearing you, seeing your mouth move. Melissa, do you need to
Oh, hey, sorry about that. So yeah, there's the question in the chat. So do all terminals have that diagram when Git LG is run?
I hope so. So my Git was installed when I got the laptop from the company.
Okay.
I think they just installed Git for Mac, and then my son told me Git has this thing can show you branches, so I just Googled.
Oh, I see. So yeah, that is a general tool of Git.
Yeah.
Cool.
And there's another tool. It starts a different application, the UI-like application. See, I don't remember that one. Arnold gave me that one. See if oh, no one. What is it? Did I get it from somewhere else? Not here. I forgot that. It's a separate tool you can use. There's pop up a window and show you in different ways. But this one is just there, and I think it's clear enough.
So someone in the chat posted formatted like format suggestion possibly.
Format what?
Oh, it looks like someone in the chat recommended like this one line of code to try try putting out the graph.
So I posted, I think people use different areas for another command. So some terminal might discover that. But if you're running with a view and it doesn't work for you, you can follow the link that I posted and get the complete command.
So it's really hard to hear you.
Yeah, Artem, I think your mic might be distorted a little bit.
Okay, so basically, Artem posted a command we can use.
Sorry, is it better now? Is it better?
Yeah, a lot better.
Cool. Sorry. Yeah, sorry, I wasn't using my headphones. So I posted the link, and I think the git LG that you ran, it's an alias for another command, and it might just be configured in your terminal by default. But if you follow the link, you can find the complete command it resolves. So you can just run this command, and it works for everyone.
All right, thanks.
Yeah, no problem.
I'm having trouble to see the Git chat window. So I'm not, okay, now I see it, okay. Thank you. Where did it go? Oh, what? I guess I'm just gonna read like, oh, it's on the back. Okay. Nice, thanks. Anything else?
So I had a question. So you mentioned you don't use GitHub with work, but you do use Git. So is it common for companies to use their own like version control hosting for Git?
I think so. We use a provider called Bitbucket.
Oh, okay, cool.
So that's what we use. See all the repositories here, and we have a UI too. And I know when I was at my previous company, we mainly use Microsoft Team Foundation for control, but some teams using Git. I'm not sure which one they use. Yeah.
Okay, cool.
Nice. Yeah. Anything else? All right. What we are going to do now is we going to do the push again so that it's into the remote git push. Taking a little bit time. So we see everything here now. Sometimes if somebody else also making change and pushed and you're making change, you had push, you probably will have conflict. So you need to do the same resolve conflict. Okay, in the join here, I pushed everything in the local into remote. Move on. All right. Now I'm going to talk about our typical workflow at my company. As we say, teams have their own branches, and then team member, like within a team, you have more than one developer, they need to collaborate as well. So what we do is we have a branch that's not the main on the remote repository as well. So we have a remote branch, and then individual developers can push into the remote branch rather than push into remote main. Let's do that. So I want to create a branch on my local system, but I don't want my branch to be based on my local mast. I want my branch to be based on the mast on GitHub so that I can put in changes anytime. So what we do is git check out origin. Origin is my remote. And I need to do main, that's the remote main, -b to create a new branch. I call it dev branch. So now we've created it, and you can see automatically switch to that branch as well. Let's see what it looks like. It's switched. Okay, I do this git branch -vv, give you more verbose information. Here it's telling me my main branch is connected to the remote main branch. In the Git, it's called the upstream. So the upstream is when you want to pull changes into your branch, it pulls from this upstream. So my test branch, because when I created, I didn't specify that I wanted to create based on the remote one. It doesn't have that. And then that branch based on its upstream is the remote main branch. Okay, we've done that. What else do I need to do? Check out. Okay, so now I create a local branch and I want to create a remote one. I git push origin. Origin means my remote repository. I'll push that branch into there. Now we finish push. Let's look what it is like. So here, now it's showing main. It's showing you there's one branch. You can choose to see what's in that branch. Because we have not made any change in that branch, it looks like the same as main. We should have two branches. Wasn't updated. Let's see, show here. Okay, shows the branches. All right. Yeah. So that's you create your local branch based on the remote master. You push your branch. Now your remote has a branch. Let's do some work now. So we are the right branch. Pretending writing more code. File 3.txt. Now we have it, and we want to commit and first commit from that branch. Oh, forgot that. Yes, you cannot use this for the untracked file. Do the add command explicitly. We've made a change. Okay, I'm just going to push it. So this change now is on my local dev branch. I'm going to push it to the remote dev branch. Okay. So that's what main branch look like. That's what remote branch, that branch look like. We have that file. Yeah. I finished creating the commit on my local branch, pushed it to the remote branch. Now, the more interesting part, especially for collaboration, is pull request. So now here, that branch has some change that's not in main. And if you want to merge into main and you want to protect your main, you will ask people to not just merge, create a pull request first. A pull request basically say, I request to merge this code, please review it. So let's see, this has a very nice button here. Let's just say compare and pull request. In here, it said the pull request is from the dev branch into main. And you can write some comments. This is okay. You create a pull request. Okay, now we are in the pull request. This view is just the conversations, comments. If you go to the commit, so you see it sees the commits in this pull request. Yes, you have to go further into the commit to see the change. So once you create this pull request, you have people reviewing your pull request. For example, you have a team of 3 working on the same project, and you make the change, and then your classmate need to review your change. They look at it, they say, yeah, you wrote this code. They can comment, no, you are missing something. Comment that, so, and then gets back to you, you make more changes. Or they said it's good. That's that. Then they can say, okay, I don't think it's good, leave comment, or I can approve, say it looks good. Oh, that's request change, okay. This is grayed out for me because I'm the person created PR, the pull request, I cannot do it, but others can do it, can approve. So once people are okay for you to merge, I think, how do we do this? There's a merge button somewhere. Oh yes, down below. Once everything is okay, you have permission, you merge this. Confirm merge. All right. Now let's look at what main is like. So main got the commit from your test branch. Right. So we went through merge from your remote branch into the remote main after pull request. Let's just pretend that I didn't make that change. Somebody else made that change into the remote repository. How can I get it? Say, I'm going to go back to main because that branch already have the change. Okay. So here it says I'm up to date, which is false, not true. It's because my local Git doesn't have the information about the remote Git. So what I'm gonna do is git fetch to fetch the metadata information, and it fetched it. What's this tell me? And then you will say I'm behind by 2 commits. The remote has 2 more. Let's see what we have now. We have the last merge from test branch. So let's pull in the change. You just git pull. We've got it. Let's see. So that was what we were at. We put in a commit from the dev branch and put in the merge commit. Here's shows where things are. Test branch is quite behind, dev branch is here, and then the main has the merge commit. I don't think LG is interesting now. We can take a look at this. We're showing the dev branch. We have a test branch and dev branch. All right. Anything about making remote branch and merging and PRs? All right, we are good. The next one, I'm not going to do a demo, just going to talk about it. You probably already get a concept from all the things I'm doing, but it's just showing another graph. Say we have 2 developers. They all use this remote repository. And then you have first developer did things, made a change. Oops. The blue one made a change in local, pushed to the remote branch, pushed, then merged into remote main. And then you put it to the local master. That's what we did. And then you have another developer doing something similar. They made a change their local dev branch. They pushed to their remote dev branch. They merge, so it gets to main. And then you can do a pull. You can pull it into your dev branch because we've seen before. My dev branch, this upstream is this remote main, or you can put it into your master branch. That's how you will collaborate with other people. Any question? No? Okay. Oh, good. I'm making good progress. I'm not too far behind. Fork. Fork basically is making a copy of somebody else's repository. I guess my son is not joining me. The advantage of that is that you have a copy, you can play with it, or your team can play with it, doing whatever you want, experiments or whatever, without affecting the original repository. But also you can still, if you have some change you think is very valuable and correct, you can create pull requests against the original repository. So that you can get in your code into the original repository. Let's do that operation. It should be easy. Here, I need to go to So I'm going to fork my son's repository. He definitely have more interesting repository name than mine. Mine is so dry. So here's the fork button. I already forked it. Let's see if I can do it again. I already forked it, so it didn't really, but I just got back to the one I forked before. And then that's your forked repository. You can do the same. You can git clone this onto your local machine. I already did. That was the one. You make your changes. yeah, that's what I want to show and make some changes. CD that repository. Okay, I'm just going to do it in main now to save us time. Oh, actually, I created that branch. I'm doing that. Okay. Echo. Someone else code file2.txt. Oops. What did it? Add. So we have a commit here now. Let's make sure I have the right upstream setup. I do. So this dev branch is upstream is my own forked repository. I'm going to push it. All right, I've pushed something. It shows up here. Let's say I want to create pull request. And here you can choose. So this, I guess I changed the default. It says from which repository, which branch to which repository, which branch. Here, I can choose my own repository or the one that I forked from. The more interesting thing is I want to do it to the one I forked from. And let's see, let's push it to the main. So you do the same thing, you create pull request. That's done. And see, this time, because it wasn't my own repository, I don't have the merge button. I cannot do it. Only my son can do it. He will need to review my change and merge it or give approval and merge it. That's what I want to demo. I was Googling, like, if I fork the repository, if they made some change, how can I get that change? There are several commands involved. It's listed here. And then something else I think that's very useful, but I don't have the time to go through demo, is how you revert changes. I think it's common that during development, we will write something and later we find out, okay, that was wrong, or I want to try something different. You can revert your changes. So that depends on which state your code is. If it's unstaged, like you didn't do the git add command, you just do the reset hard. If it has staged, but you have not committed, you unstage it and then you do the reset hard. If you have committed it, but you have not pushed it to the remote, it's all your local stuff, and you reverting it doesn't affect anybody else, you can git reset head tilde. This is a number. So head tilde 0 is doing nothing. Head tilde 1 means go back 1 commit, 2 go back 2 commits, whatever number you want to use. And then you do the reset hard. Once you have committed and you've pushed something to the remote repository, that means that your change probably have been pulled by somebody else. So in this case, I do not recommend you use the git reset hard. I recommend you use the git revert SHA. SHA number is this number. So say if I don't want this change, I copy this number, put it into this command. Maybe I can just do it very quick. Let's move. Can I do the initial one? Maybe not the initial. Okay, it gives me an automatic message. I'm going to take it. So you can see that the commit was still there, but then you have a revert commit that reverts the change. And that file one, because I reverted it, it's no longer there. So that's, you revert it, but keeps a history. And then you will not mess up other people who got to commit already. So another useful thing here is git ref log. So git log shows the history of the commits. Git ref log shows the history of your operation. Wait, what did I do? Not supposed to be like that. Something got wrong. Try another. I did that the other day. It was working. Yeah, this one. That shows your operation on Git. It shows even the pull command, checkout command, and you can revert to those shots that will undo your Git, whatever Git operation. I don't use that very often, probably once or twice. It was a lifesaver. When I first started using Git, maybe 2 months into it, I was working, I made a lot of changes, and I forgot what operation I did. I didn't see any of my code change. I was panicking, said, no, I lost a week's of work. And my coworker came and showed me this and said, oh, you did something wrong here. Let's revert back before that operation. All right, that's all the stuff I have. Q&A section.
Heidi, I can share my screen for this if you want.
Okay, let me do that.
Let me hop back on. Okay. Thank you so much, Heidi, for going through that. Lots of information, but it's super necessary for all of us as students to know, especially if you're going into the field of engineering/CS. So are there any questions for Heidi? It could be about this presentation. It could just be about, her graduating. We're all trying to get where she is now. She's a lead at her company. So, I mean, that's all what we want to do, right? So any questions, you can type them in the chat or you can unmute yourself as well.
GitHub will essentially be a place for people to share codes. Yeah, that's great. It's a very easy place. When you have group project, then simple one probably okay, don't have to use it. You have a more complicated one, I recommend that you use GitHub to work with your teammates.
Awesome. Any other questions? If not, we can move on as well. Okay, I'll take the silence as a no for now. But again, if you have any more, we only have like 2 more slides, but if you have some, just shoot them in the chat. Melissa, this is for her club.
Yeah, so this is the ACM contacts. We have an Instagram that we post to regularly. Our email, if you want to get in contact with us, or another great way is Slack. You can also connect with us on LinkedIn, and we share some resources there as well. And we're also connected to a lot of the alumni and other great resources that our school has to offer. And we have our SFSU ACM.club website, which we are about to make open for everyone to contribute to. So if you're a web developer or you're interested in web development, that will soon be open on GitHub, and you can make a contribution. You can fork it, add whatever you think you could add to it, and then do a pull request.
Awesome. Okay, for the SF Hack side of things, this is our social media. You can scan these links or go to the link here and in the chat, and it'll take you to all of our social medias, our LinkedIn, Instagram, Twitter, everything. And you can scan the one on the right to join our server on Discord. Along with the great presentation Heidi just gave us, we're also going to be having other presentations throughout the semester and through the spring semester. Our next one is going to be on October 20th, again from 6 to 7 p.m. and it'll still be the same Zoom link, and it's going to be hosted by Sasha Haberling, an software engineer from Google. And you're going to learn how to use the Google Engine app, or Google App Engine, sorry, and you'll learn how to create an app through it and run it, which is great as well. So please keep this on your calendars if you're interested. And if not, there are a bunch of other events coming up where you guys can join. I just want to say thank you, Heidi, for coming. And if you guys can thank Heidi as well, you should honestly give her a big round of applause. It is super beneficial to have industry professionals like Heidi come and teach us as students. I took a lot away from this presentation and workshop, and I hope you guys did too. If there are no further questions for Heidi or about GitHub, or from Melissa and I for our clubs, feel free to drop out because this is the end of our workshop. But again, thank you so much, Heidi, for doing this. And thank you to your son as well for assisting with this too.
Thank you.
Thank you.
Good that you guys are learning. All right.
Yeah.
Have a good rest of the semester. All right. Bye-bye.
Thank you, Heidi.
You're welcome.